Hey, this is Dan. This is the Chapter 7, 8, 9 Solutions video, Fall 2012. This test was structured a little bit different than others. I try to make it only a few problems, but every problem has all the same steps and procedures as far as hypothesis test, type 1 and type 2 errors, and confidence intervals. So in this first one, it's a hypothesis test with one proportion. So the null hypothesis is P is 34%. That means 34% of American fathers take no responsibility. The alternative is that it's greater than. And so I make sure you always want to see the population parameter here in the null and alternative hypothesis. In this case, it's population proportion. And then over here, we calculate the z-score, and we get 2.33. So that means the sample was 2.33 standard deviations above the normal, which, if we look that up on our z-table, is about 1%. There's about a 1% chance that you would get this result by random chance if 34% is accurate. So since our p-value is less than 0.05, we reject the null hypothesis, and that means there is significant evidence the percent of fathers not taking responsibility in Littleton, the city, is greater than 34%. So then the type 1 and type 2 errors would be, type 1 is when we reject the null hypothesis. So in this case, like what we did here, reject the null hypothesis, say the proportion is higher than 34%, but the reality it is not, like we falsely rejected. So the type 2 error would be, hey, we do not reject, there is not significant difference, but there really is, the percentage is really higher. And then the confidence interval, you take p hat, which is 0.41, 1.96 is what we use for 95% confidence, and then here's the standard error. So our 95% confidence interval is between about 0.347 and 0.473, and it says, does the interval contain 34%? The answer is no, which kind of confirms what we said up here, that 34% is not in that interval. So if we were going to make an estimate for the true proportion of fathers, it would be between, we're 95% confident it's somewhere here, so that means no, it's not in there, and that actually backs up what we found up here to reject the null. And number 2, this is with one mean. Our null hypothesis is the mean is supposed to be 30, that's what they're supposed to weigh. We take a sample, and we're trying to see if they're actually giving us ball bearings that are too light. So our alternative is that the population mean is less than 30 grams. So we calculate our t-score here, and we get 1.52. If you look up negative 1.52 on your t-table, which is, we use 15 degrees of freedom, the p-value is between 5 and 10%, and since that's bigger than our significance level of 0.01, our p-value, we do not reject. It's far away, but it's not significantly far away to prove that the mean is not 30 or more. So we do not reject the null hypothesis. We do not have significant evidence the mean weight is under 30 grams. I mean, it might, but we just don't have enough evidence to be sure to accuse the store of doing this. What we observed may have just happened by random chance. And then the type 1 and type 2 errors are, if we reject the null and say the ball bearings are light, we accuse them of selling us light ball bearings, but we're wrong. That would be a type 1 error. And then type 2 error might, maybe that happened here. We failed to reject the null hypothesis. We said the ball bearings were not, were fine, but they really weren't. They were really light. And then the 95% confidence interval, there's our sample mean, plus or minus, and then our t-multiplier here is 2.131, and we get that from our t-table if you look under 95% with 15 degrees of freedom. There's our standard error. So we are 95% confident the true mean weight of the ball bearings is somewhere between 26 and 30.6. And you can see that 30 is in this interval. So it is possible that the true mean might be 30. It's towards the high end of it, but we don't have enough evidence to say it's not. So does it contain 30 grams? Yes. Are they selling light ball bearings? No. Or no, we don't have enough evidence to say that. On 3, this is a difference between two proportions. We've got two sample proportions here of defect rates, and we're trying to see if there's a significant difference. So our null hypothesis is that the two manufacturers have the equal defective rates. The alternative is that they don't, so it's a two-tailed. Calculate the z-score, which is 1.39, and we double that, and we look that up on the z-table, which is 0.0825. Double it because it's two-tailed, so about a 16.5% chance that we would observe this much difference by random chance. Since the p-value is greater than 0.05, we do not reject the null hypothesis, which means we do not have enough evidence that the rates are different between plant A and plant B. The type 1 error would be to reject that and say the defective rates are different, but they're really not. And type 2 is what we may have happened here because we failed to reject the null and say there's no difference, but there really was a difference. And then the 95% confidence interval, so there's the two sample proportions. We use 1.96 for 95%. There's our standard error again. So we're 95% confident the true difference in these two proportions is between, looks like about negative 0.05 and positive 1, a little less than that. So it says, based on our confidence interval, the defective rate's different. There would be no, because 0 is in that interval. So it is possible there is no difference here based on our confidence interval. And number 4, it's difference between two means. So our null hypothesis is that the mean for group A is, or company A is equal to the mean for group B. Our alternative is that's not. So this is two-tailed again. We calculate our t-score. Some people forgot to square these. A lot of times they put the standard deviation, but they didn't square it to get the variance. We get 2.25. If you look up 2.25, and we're going to look in row, we take n1 plus n2 minus 2, so there's 98 degrees of freedom, which we can't go quite, but we go one row above that. And we can see that our p-value with two-tailed is between 2 and 5%. Excuse me. And then we had a p-value. So our p-value is between 2 and 5%, and our alpha level was 0.05, which means it's less than 0.05. So we're going to reject the null and say there is significant evidence the mean response times are not the same. So there is a difference here. Type 1 error would be to say the mean response times are not equal, but they are, which is what maybe happened here. We're saying they're not the same, but they really are. And the type 2 error say the mean response times are equal, just like, just do not reject our null. Or fail to reject it, but they're really not equal would be that error. And then the 95% confidence interval, again, here's our two sample means. We use 1.992 for our t multiplier, and it's off the t-table. And then there's our standard error. And so we get a 95% confidence interval that the difference between them is between 0.08 and 1.32, I think it's minutes, yeah. So, and since 0 is not in that interval, it says, are the response times different? Yes, and 0 is not in there, so that kind of backs that claim up. Number 5 is on dependent samples. So our null hypothesis is that, this is when we have, this is a before and after they're doing a crop test here. The null hypothesis is that there'd be no difference, so the mean before and after is, the difference between those is nothing. The alternative is that there would be a difference in the mean or the yield. We calculate our t-score here, and we get 5, which is a really large t-score. And if we look that up on our row 9 of our t-table, p-value is almost 0, which means we would reject the null hypothesis, and we do have significant evidence that the additive does improve yield. Type 1 error, we say that it does improve, but it really does not. The type 2 error, we say the additive does not improve yield, but it really does. And then here's our 95% confidence interval. 2.26 or 2.262 is our t multiplier, which you get off the t-table from row 9. And so we're 95% confident the true mean improvement is between about a half and 1.3 bushels per acre, or whatever it is. And does that? Yes, that does show that there is significant, and 0 is not in the interval, so that backs that up, that the treatment did improve yields. Then the last one here, it talks about loud music on teenagers. It said that there was evidence. That means there was significant evidence, which means they would have rejected the null hypothesis, because your null hypothesis is that loud music wouldn't affect their hearing. The alternative is that it does. But in this case, there was evidence. That means they got a test statistic that was really far away from normal. And they rejected this at the 0.01 level. So that means it was below 1% chance that they would get this much of a difference in hearing ability. So the question is, would they have made the same decision at 0.05 and 0.1? And the answer would be yes. Those are definitely below those alpha levels as well. So there was 66 points in this test. I did not curve it at all. There was plenty of good scores. And hopefully this gets you ready for the final.